Okay, welcome back. Today we'll be talking about applications using systems of equations. So let's go ahead and take a look at our first example. Assume all Phoenix College courses are either worth 3 or 4 credits. The cross-country team is taking a total of 40 courses that are worth 144 credits. How many 3-credit courses and how many 4-credit courses are being taken? So the first thing is we need to identify our unknowns. Let's let x equal the number of 3-credit classes and y equal the number of 4-credit classes. The first thing we need to recognize here is that the team is taking a total of 40 courses. Therefore, our first equation would have to be x plus y must equal 40. Now the next equation is going to deal with the total number of credit hours. There's a total of 144 credit hours, but every x is worth 3 credits, so we'd have 3 times the number of 3-credit courses, plus every y is worth 4 credits, so 4 credits times every 4-credit class must equal the total number of credit hours, which is 144. Now remember, we can solve this system using a variety of methods. I'm going to use the elimination method, and I'm going to eliminate the x terms. So since this is 3x, I want this to be a negative 3x, therefore I'll multiply this first equation by negative 3. So the result would be negative 3x minus 3y is equal to negative 120. And we can leave the second equation in its original form. And the reason we did this is now, since the x terms are opposites, these will add to 0. This will add to a y, or a 1y. And this will add to 24. So y equals 24, therefore we know the team is taking 24 4-credit courses, but we have to perform substitution into one of these original equations in order to find x. It seems like it'd be pretty easy to use this first equation to solve for x. Since we know y is 24, we can solve this for x equals 16. Therefore we can conclude the team is taking 16 3-credit courses since x equals 16, and 24 4-credit courses since y is equal to 24. Let's go ahead and take a look at this example. HomeMart charges $3.50 for a CFL light bulb, and Supply Depot charges $2.50 for a CFL light bulb that doesn't last quite as long. If your apartment complex lost the invoice but knew they purchased 300 bulbs and spent $885, how many bulbs were purchased from each store? So again, we'll identify our variables. Let's let x equal the number of bulbs from HomeMart and y equal the number of bulbs from the Supply Depot. Since we know we purchased 300 light bulbs, we should be able to conclude that x plus y must equal 300. Next, we're going to have a cost equation. We know they spent $885, but every x costs $3.50. So 3.5 times x plus every y costs $2.50, so that'd be $2.50 times the number of bulbs purchased from Supply Depot must equal $885. Now I'm going to use elimination, and I'm going to eliminate the y terms this time. However, I could also use the method of substitution. So if I want to eliminate the y terms, I'll multiply this first equation by negative 2.5, since this is a positive 2.5y. So the result of multiplying everything by negative 2.5 would be negative 2.5x minus 2.5y equals negative 750. We'll leave the second equation in its original form. So when we add these equations together, the y terms are opposites. That will simplify to 0. So we're left with x equal to 135. So we know that there were 135 bulbs purchased from, there were 135 bulbs purchased from the HomeMart store. Since we know the sum of x and y must equal 300, we could replace x with 135, but you can probably see that since the sum equals 300, y must equal 165. As a result, we can conclude 135 bulbs were purchased from HomeMart and 165 bulbs were purchased from Supply Depot. Now let's take a look at a different type of problem. Groundworks charges $8 per pound for premium roast coffee and $4.50 for value roast coffee. How much of each type should be used to make a 10-pound blend that would cost $5.90 per pound. Again, this is important that we identify what our variables represent. X will be the amount of $8 per pound coffee, and Y will equal the amount of $4.50 per pound coffee. Since our blend will weigh 10 pounds, we can conclude that X plus Y must equal 10. The next equation will be what I'll call either the cost or value equation. Every pound of X costs $8, so $8 times X plus every pound of Y costs $4.50 must equal the value of the blend. Well, the value of the blend is $5.90, but it has to be times the amount, and the amount will be the sum of X and Y. So what we have here is $8 times the amount of X plus $4.50 times the amount of Y must equal $5.90 times the amount of the mix, which would be the sum of X and Y. Now to solve this system, I am going to use the substitution method, and what I'm going to do is solve this equation for X. I'll subtract Y on both sides. Now let's rewrite this equation performing substitution. We would have 8 times X, which is 10 minus Y, plus 4.5Y must equal 5.9 times X plus Y. But we can save some time if we recognize that X plus Y does equal 10, so we'll replace this with 10. We have one equation with one unknown, so we now just have to solve this equation and we'll have Y. So let's go ahead and clear the parentheses and solve. So here I distributed and here I multiplied by 10. Let's combine our like terms. Now we'll subtract 80 on both sides. That would give us a negative 21 on the right side, dividing by negative 3.5. We have Y equal to 6, so therefore we have 6 pounds at $4.50. We can do mental substitution here. X is equal to 10 minus Y, or 10 minus 6, so we can conclude that X equals 4. So we can conclude the 10-pound blend will consist of 4 pounds at $8 per pound and 6 pounds at $4.50 per pound. Okay, we have time for one more. A train leaves Prescott, Arizona and travels north through the Grand Canyon at a speed of 25 miles per hour. 1.5 hours later, an express train leaves a parallel track and travels north at 60 miles per hour. How far from the starting station will they meet? So this problem involves the formula distance equals rate times time. So let's go ahead and record what we know in a table. So the idea behind this problem is train 1 leaves the station traveling 25 miles per hour, and then an hour and a half later train 2 leaves the same station on a parallel track. It's traveling faster, and the question is, how far from the starting point will they actually meet? Somewhere out here. They'll be in the same place at the same time. So let's set this up. In either case, we don't know the distance. So for the slow train, I'll call this distance 1, d sub 1. The rate is 25 miles per hour. We don't know time, so we'll set time equal to t. Now for the faster train, again, we don't know the distance, so we'll call it d2. But we should recognize that when they meet, d1 will equal d2. The rate of the faster train is 60 miles per hour. However, since this train is leaving 1.5 hours later, we must represent the time as t minus 1.5. Since this train has 1.5 hours less time than train 1, we have to represent the time as t minus 1.5. So our first equation is d equals 25t, and our second equation is d equals 60 times t minus 1.5. Since we want to know when they're going to meet, we know that these two d's would be equal to each other. So what we can do here is solve this system using substitution. Wherever we see a d in the second equation, we can replace it with 25t. So performing the substitution, we would have 25t is equal to 60 times t minus 1.5. So we'll distribute here, isolate t on both sides by subtracting 60t on both sides. That would give us negative 35t equal to negative 90. Dividing both sides by negative 35, t is approximately 2.57 hours. Now the question asks how far from the starting station will they meet? So this is not the answer we're looking for. So to find the distance, we have to pick one of these equations and replace t with 2.57. let's go ahead and use the first equation. Multiplying here, we're going to get approximately 64.25 miles. So after 64.25 miles, these trains will be in the same position at the same time. I hope you found this video helpful.